I'm back again to tell you about extragalactic science. I hope that you can see my screen. Yes, I cannot see you. So,
Yes,
Yes.
yes, you can.
Yes.
yes, thank you. So now I wanted to show you an example of how to query for extragalactic science in the Fink API. As again, I'm gonna try the exercise of running real time. We will look a little bit in added values that Fink has, like the cross match with Sinbad, the machine learning classifications, and now more specifically in Supernova with the three models that we have and the extra features of color or rate. So you set up the environment. And the first case I wanted to show you is let's find some AGNs that are known. So you can query our API to get the latest alerts. So that's why we're using the latest API. We're gonna search for AGNs that have been classified and uploaded to Sinbad using the CDS crossmatch service. I'm gonna search only for 5 alerts because there's a lot of AGNs. And for reproducibility, we just put the start date and stop date, but you can absolutely comment these and run these to find the latest ones that have been observed by CTF, and you will transform it into a pandas data frame. So here is a little bit more information on that. And now we're gonna see what we have as information. So of course the CDS crossmatch is an AGN. Then you'll have all these machine learning classifications. Mu lens is microlensing, so hopefully it's not a microlensing event. Random forest score will be for the supernova score, early supernova, asteroids, supernova versus all types of supernova of other types of transients, or 1A versus non 1A, and of course CTF data and other data that we have added. So maybe you want to see one of the photometry of these AGN. So you get an object, you get the object ID, you want to see all the photometry that we have. So you will carry through the API objects. You use the name that we just put up here. We're gonna get it in JSON format with all the upper limits because you can also just see the detections. And for reproducibility, again, I'm just putting a time frame, but you can change this to get the light curve for all the points that you have. Actually, we can try to do it right now. Let's see if this time, if I don't comment things, it works. So now we're gonna plot it. Again, there is a little code that we have. You can copy paste it and you call it and you say plot light curve single object, and you have the light curve and AGN. You can see it's rising in all the detections with limits here in open triangles, and the upper triangles are measurements that don't pass the quality cuts. Now I'm gonna switch to another science topic, which is early supernova candidates. So early supernova candidates is a tag that we have defined and provided by Fink. Like all of our tags, you can actually create a tag by submitting a community project. So you can join us and say, I want to tag this type of objects, and you will get the live stream, and also people can query it in the API. So it requires that the alert has no known transient association for early supernova, except if it's like a host galaxy, that's okay. It doesn't have many detections, and we ask that 2 of the 3 machine learning classifiers have a confident that it is, and especially this one that is the random forest that we have prepared to select only early supernova, okay? So what we're gonna do is query the API in the latest alerts, all that we have tagged as early supernova candidates. I'm going to query for 200 alerts within a date, but you can change it for last night if you want. That converts us to a pandas. And now one of the things that you may say is like, oh, cool, I have all these alerts. Can we see the color of these alerts, for example? So I am just displaying here the alerts again, just in an inverse order. And you can see that we have the rate of increase in the magnitudes in RNG, but we also have a rate in color and a color, okay? And you want maybe to see the color of these alerts, and you can see, oh, well, there are some that are negative colors, G minus R, which means they're redder, and these ones are bluer. So maybe you want to select bluer early supernova because you're interested in something that looks like a supernova rising, but it looks a little bit blue. So you select them, usual pandas data frame, and now you may have a survey for follow-up that you want to put a limit in the magnitude that you have. So you want something that is brighter than 19, so you can select it using the latest magnitude observed, which is this one, and you run it and you have all these events. Okay, you can see some of them are the same. It just means that we have two alerts very close together. um, Now you choose one of them and you want to see the photometry. So but maybe you want to put a threshold in the probability of the machine learning classifier quite big, 0.8 for example, and then you put it here as a pandas data frame, and you want to see that object. You request it through the objects API. You put the name of the object, and you get the light curve. Now I'm gonna plot the light curve. You can see it's a very nice supernova light curve. And maybe you want to actually visualize the color evolution. So I am doing a plot of the color evolution for this object. Remember that color is only computed when we have two measurements, one G and one R in the same night. Some of them are missing. So this is the color evolution against the modified Julian date. Because this is not that beautiful, I actually opened a supernova in the web portal, and you can see in the supernova tab up here, you don't only not have the machine learning scores, but you have the color magnitude evolution that you can see here for each of the nights that we have two measurements, and you can see that here in green, but sometimes you don't have the GNR, so you don't have a color. And of course, if you want to see the rate, so rate is divided by day, you can have it as well when it's possible. So you can play a little bit with that. Coming back to the API, I'm going to stop here with the early supernova, and maybe you're doing a posteriori analysis and you want to find all the spectroscopically known type 1a supernova in Fink. You want to see the photometry. So what we do is that we cross-match objects against the TNS database. So we have heard about this in the workshop already. So what we do is an API query asking for that. So we search all, thank you. We search all the alerts, the latest alerts that were classified as TNS as a type 1a supernova. We're searching 10 alerts, and for reproducibility, we're putting a date limit, but you can just ask the latest ones in the last night. So you have this list of objects in a pandas data frame, like always. I like pandas data frames. And I'm gonna visualize one of those light curves. So I'm gonna select one of them and query the object API to get them and plot the light curve. So you can see this is a spectroscopically known type 1a supernova. It's very nice. And maybe you want to visualize which machine learning scores were associated with this known type of supernova. So you can see that here. You can see sometimes it didn't get a very high score. It's part of the things that we're working on between passing CTF1 and CTF2, improving those machine learning classification scores. I remind you that RF score is designed only for early supernova classification, so don't worry if it's not good when after you have passed the peak, which is what exactly you have here. And the last thing I wanted to tell you is you can actually search for supernova that actually have close by galaxies, not necessarily their host galaxies, by looking at the closest neighboring Sinbad. So what we search is for alerts that have a CDS cross-match galaxy, and you can find a couple of objects and you can play with it and maybe get the thumbnails. So for that, we query the objects API with the cutouts, okay? And now I'm gonna plot it and you can see it here. So you can see that it's centered in the supernova. So you can see it's a faraway galaxy. And if you want to see with the cutout service, you can just ask for the cutout service here, which I really like those images because they look like astronomical images. So basically you have seen Fink's API query for latest alerts using known catalog types, using TNS spectroscopic classifications, using things that we have selected with our machine learning algorithm at potential supernova, and getting all the information with that. Of course, if you have any questions, please let me know. And of course, we accept suggestions.
All right, so we don't really have time for questions now, but feel free to post them in the Slack and we'll get them answered offline.